In this video, we're going to look at some equations of exponential functions, and we're going to try to identify their key features. Let me zoom in here on the top left-hand side where I wrote out some parts. Our exponential functions are going to be written in the form y equals a times b to the x power. And if we are given an equation and we're looking at it, whatever a is, it's going to represent our initial value, which is also known as the y-intercept of this exponential function. The number that has the exponent, indicated here by b, that's got x as the exponent, is our growth or decay factor. So we can tell if a function is growing or decaying just based on what this number is. If b is bigger than 1, so if b is bigger than 1, it's going to be considered growth. If b is smaller than 1, it's going to be considered decay. Now, if they are growth or decay, we can determine the rate of growth or the rate of decay by looking at these following two equations. B is equal to 1 plus r if it's exponential growth, and b is equal to 1 minus r if it's exponential decay, where r is the rate of growth or decay. All right, let's look here at this first problem. So we want to identify the key parts of this exponential function. We'll start with the 38. So remember that our exponential functions are going to be in that form y equals a times b to the x power. Well, a is equal to 38, which means that is the initial value. And from here, we look and we identify what b is. B is equal to 0.29. Well, since 0.29 is less than 1, we call that decay. And the last thing to find is, what is the rate of percent increase or decrease? Well, it's decaying. So since it's a decaying function, b is equal to 1 minus r. And so we're just going to put in for b and solve for r. So b is equal to 0.29. So 0.29 equals 1 minus r. And then we go solve for r. So I work here, I subtract 1. And we're going to wind up getting negative 0.71 is equal to negative r. So r is equal to 0.71 after I divide by a negative. Now, since you're asking for the percent, that's just the decimal form. The percent decrease is 71%. 71% decrease. All right, let's look here at this next problem. We want to do the same thing. So we're given an exponential function. I know it's an exponential function because I have x in the exponent. And it's in the form y equals a times b to the x power. So the initial value is whatever a is. Well, a in this case is going to be 46. Now we want to identify what b is. So b is going to be the number that has the exponent. So b is equal to 1.034. Now, based on the size of that number, since that number is larger than 1, this is going to be considered a growth function, an exponential growth function. Now, to find that percent increase, what you're going to do, since it's exponential growth, b is equal to 1 plus r. So we're going to put 1.034 in where the b is and say it equals 1 plus r. We subtract the 1 to the other side, and we get 0.034 is equal to r. Well, we're going to convert that into a percent, so you move the decimal 2 places to the right, and so we get a 3.4% rate of increase. Okay, here we're going to look at writing the equation of an exponential function, and we're kind of look at this in two ways, from a table and from two coordinates, which I have below. So we're going to write the equation that form y equals a times b to the x. So I'm going to zoom in to this first problem. So y equals a times b to the x power. And we start by trying to find our initial value. Well, the initial value is going to be what y equals when x equals 0. And so we're going to look for that point in our table, and that is going to be when y equals 4, when x is equal to 0. So what that means is a is equal to 4. So our initial value is also known as the y-intercept. So we currently have y equals 4 times b to the x power. And so from here, what we're going to do is we are going to use another coordinate, and we're going to solve for b. So we're going to go pick, doesn't matter, let's go pick the next data point. So the next data point that we have is 1, 8. Let me change colors here. We have a data point 1, 8. Now 1 is x, 8 is y. And so what we're going to do is we're going to plug in. We're going to plug in for x and y. So y is 8. So I have 8 equals 4 times b, x is 1. And now we're going to solve. Well, b to the 1 power is just b. So I got 8 equals 4 times b. We divide by 4. And we get 2. So 2 is equal to b. Now what that means is we can now write our equation. Our equation is y equals 4 times 2 to the x power. All right, let's do this process again. So we're going to write an exponential equation in the form of y equals a times b to the x power. Now, the way I know it's exponential is because I look at the y values and how they're changing. Like if I look at the y values, I go from 0.27 to 0.9 to 0.9 to 0.3, 0.3 to 0.1. What we're doing is we are multiplying by 1/3 every time. If I multiply by a number every time, it's considered exponential pattern. We did that in a previous video. All right, but to get back to writing our equation. So if we're writing our equation here, we're going to start by finding the initial value. I'm going to abbreviate that as IV. And our initial value is going to be a. Well, a is the y value when x is 0. So the y value when x is 0 is 2.7. So I got that value to be 2.7. So I have y equals 2.7 times b to the x power. Now, b, we're going to see here in just a minute that b is that number that we found that we're multiplying by every single time. You get from one number to the next. But another way of doing that is the same way we did in the previous problem, where we're going to take the next data point, since we know it's exponential. And we're going to use that point where y is equal to 0.9 when x is equal to 1. And we're going to solve for b. So 0.9 is equal to 2.7 times b to the 1 power. Well, b to the 1 is just b, so what we're going to do is we're just going to divide by 2.7 on both sides. And 0.9 divided by 0.7 is 1/3. And so b, see how b turned out to be the same number that we multiplied by, is 1/3. So our equation of this exponential function is y equals 2.7 times 1/3 to the x power. Okay, now we're going to look at just writing the exponential function when we're only giving 2 coordinates here. And we're going to use the same process we just did from the table, even though we're just given 2 points. We're going to start with our exponential function y equals a times b to the x. Remember, a is the initial value, or also known as the y-intercept. We're given a y-intercept. That's when the x value is 0. So when x equals 0, whatever y is going to be our initial value, so 112. So we now have one critical piece of our equation. Y is equal to 112 times b to the x power. Now we just got to find b. Well, to find b, we're going to use that second point, and we're going to put in 2 for the x, 7 for the y, and we're going to solve for b. So we have 7 equals 112 times b raised to the second power. Well, I would have to divide by 112. and we get 1 over 16 is equal to b squared. So from here, we're going to solve. Now, to solve, this is the first time we've had a problem that had an exponent of 2 that we want to solve and get rid of. To get rid of the squared root, or excuse me, to get rid of b to the squared power, we have to take the squared root of both sides. And so when I take the square root of b to the second power, that is b. And so we ask ourselves, well, okay, what's the square root of 1 over 16? Well, what number times itself makes 1 over 16? That would be 1 over 4. So 1 over 4 times 1 over 4 makes 1 over 16. That is what b is. We now can write our equation of this exponential function to be y equals 112 times 1 over 4 raised to the x power. Okay, last one here. So we want to write the equation of an exponential function that passes through the point 0, 20 and 3, 1280. Well, our exponential function wants to be in the form y equals a times b to the x power. So we start by finding a. A is that initial value, or the y-intercept. A is going to be 20. So we're going to rewrite our equation with 20 where a is. So y equals 20 times b to the x. And then we go use this other point. So when we put in 3 for x, y has to equal 1280. And so we're going to write that line. And then we're going to look to try to solve from here. So I would start by dividing by 20. That gives us 64 is equal to b to the third power. And so from here we're looking at it and we try to figure out, all right, what number times itself 3 times makes 64. Now when we're in the process of doing that, what we're actually doing, to take that exponent off of the b, to take the exponent of 3 off, we're taking the cubed root. The cubed root is asking yourself what number times itself 3 times makes what the cubed root of 64 is in this case. Well, that's going to be 4. So 4 is equal to b. Now we can go and we can finally write our final equation, y equals 20 times 4 to the x power.